In Section 8 of Unit 2, we are going to learn how to add, subtract, and multiply complex numbers. Now, we're going to split this unit into 2 days. The first day, we're going to take a look at, as I said, add, subtract, and multiply complex numbers. And the second day, we're going to focus on dividing complex numbers. Okay, so when we're all done today, you're going to be able to multiply two complex numbers, much like what is seen here in the do. Our note today is we're going to take a look at words like terms, or in a sense, like parts. Because when you're dealing with complex numbers, you have not necessarily like terms, but like parts. Okay, and we're going to, so go ahead and pause this, get down your know and your do, and of course, your essential question. Now let's review for a moment. And let's review what a complex number is. Remember, a complex number is a number that can be written in this form, a plus bi. Now remember, a and b are the real numbers, and I is equal to the square root of -1. When you put those together, it makes a complex number system because remember, a is your real part, and bi is your imaginary part. So together, it makes a complex number. Okay, so we see here we have the real part and the imaginary part. Now, when you add, subtract complex numbers, you're going to add the real parts together and add the imaginary parts together. Okay, so anyway, that's just a real quick review. So let's get on to how to handle some imaginary numbers. In this slide, we have I to the first power, and of course, I to the first power is I. Now, I to the second power is -1. Now, maybe you're saying, how is it -1? Well, this is how it's -1. Because you know that I, remember, is equal to the square root of -1. Well, if you take I times I, that's equal to the square root of -1 times the square root of -1, which is equal to the square root of -1 squared, which is equal, now remember, a square undoes a square root, giving us -1. So that's where we get -1. Now, what is this I to the third power? Well, notice what we have here. I to the third power is I squared times I. And I squared is equal to -1, so that's equal to -1 times I, or -1. Now, I to the fourth is the same as I squared times I squared, and I squared is -1, so you have the same as -1 times -1, and -1 times -1 is 1. Now, I want you to see what happens. After this, you have I to the fourth times I, and remember, I to the fourth was equal to 1, times I gives you I. Now, if you look at I to the sixth, well, I to the sixth is the same as I to the fourth. Remember, I to the fourth is 1, and I squared, which is -1, so you get 1 times -1, which is -1. Now, I want you to see something. Look at this I and this I. Look at the -1 and this -1. Now, let's go ahead and do the next one and see if it comes out to be -I. Well, I to the seventh is I to the fourth times I to the third. I to the fourth, remember, is 1. I to the third is -I. So if you take 1 times -I, you get -I. Same thing. Guys, it turns out it's going to be cyclic from this point forward. So notice, I to the eighth is 1. I to the ninth is I, same as I to the first and I to the fifth. I to the 10th is -1, just like I to the sixth and I to the second are. Okay, so it just becomes cyclic. Okay, so now let's take a look at some problems where we can use this cyclic behavior to come up with what I to the whatever power is equal to. Okay, so let's take a look at this one here. So I have I to the seventh. What is I to the seventh? Well, remember that the easiest way to do this is, since it's cyclic every fourth, okay, that means I can take 4 divides into 7 how many times? Once, with a remainder of 3. So that means this is going to be 1/2 times Now remember, it goes around all the way around once and then goes back 1, 2, 3. So what was I to the third? So remember what I to the third was. And if you have in your notes, if you know what I to the third was, then that is what it's left with. So I to the third was what? Negative 1, yeah, or negative I. So you're going to times that by a negative I, so then you have 1/2 times negative I gives you negative I over 2. Okay, let's take a look at another one. What about this I to the 24th? Now, remember I to the 24th is equal to I to the, let me think here. 4 goes into 24 6 times with a remainder of 0. Okay, so that means it's going to be I to the 4th, all raised to the 6th power. And what is I to the 4th worth? I to the 4th is equal to 1, and 1 to the 6th is simply 1. Okay, that's how you take a look at this. Okay, let's take a look at the third one here. I have 4I cubed, so that's going to be 4 times, now what was I cubed again? It was negative I. Okay, so that's going to be times negative I. Plus, then you have 7 times, now let's think here. 4 goes into 9 twice with a remainder of 1. Now, I to the first power, remember, is just I. Okay, so let's figure this out. So we have 4 times negative 1, which gives us, negative I, which gives us negative 4I plus 7I, and 4I plus 7I makes it, 3I. Okay, there it is. Okay, now let you figure out this fourth one here. So pause it and work out the fourth one. Okay, now that you've worked this out, let's see what you got here. We're squaring everything inside. So 3 squared is 9. I to the 5th squared is I to the 10th. Okay, let's see. 4 goes into 10 twice, leaving us with what? A remainder of 2. Now remember, that is, what is I squared now? Okay, because I have a remainder of 2, I'm left with an I squared. So it's going to be 9, and I squared is equal to negative 1. So you multiply that by negative 1, which gives it negative 9. All right, and that's all there is to that. Okay, let's take a look at adding and subtracting some of these. First one here, I have a complex number, negative 3 plus 5i, and negative 6i. Okay, so what I'm going to do is I'm going to add the real parts and add the imaginary parts. Now, this is a real part. This is an imaginary part. The imaginary part has an I. Okay, so we're just going to add the imaginary parts. Now, before I do that, I want to show you something. Let's say that I were to do this. I were to take negative 3 plus 5x plus negative 6x. Now, if I were to have you add these together, you would what? Well, first of all, get rid of parentheses, and you get a negative 3 plus 5x plus a negative 6x. Then you would add like terms, so you would add these together. And when you added those together, you would get negative 3 minus 1x. Okay, now what we're going to do is we're going to add these two complex numbers, and we're going to compare what I get here with what I get up here. Okay, so here we go. So, let's get rid of parentheses, negative 3 plus 5i plus negative 6i. Now, what are the like parts? Well, this part and this part. Okay, so I'm going to take the negative 3, 5i plus a negative 6i makes negative 1i. And that is my answer. Now, let's compare what I have here with what I have there. Guys, what we can do is we can just pretend this I is like an X, and we can just add like terms. it'll give us the same thing as if in the situation where we're adding like parts. Okay, let's do the next one. This one here, we're going to distribute in the negative. So we will get 2i minus 3 minus a 5i. Now, what are the like parts? Well, right here. So I'm going to take negative 3, because we need to have the real part first. Remember, the a part is first. And then 2 minus 5i is negative 3i. And I'm done. Okay, let's go ahead and take a look at some... Okay, with these problems, we're going to be multiplying. And we're going to distribute in just like I would if that were a 2x. When I distribute this, it gives us a 6i. Minus, and then 2i times 5i gives us minus 10i squared. Now remember, I squared is equal to what? Negative 1. Yes. Okay, so that's going to be 6i minus 10, and I'm going to substitute that negative 1 in for I squared, giving us 6i plus 10. Now remember, we need to have it in a plus bi form. So the real part needs to be first. So this part needs to be first, and this part here needs to be second. And I'm done. Okay, let's try this one over here. Number B here. When I do this one here, let me change pen colors here. Let's try some blue. So we're going to just distribute. We're going to take the real part and multiply it into both of them. Guys, just like if this were this. 4 minus 4x times 6 minus 6x. We're going to do it the same way. All right, let me clear this out because we don't need that there. And let's go ahead and multiply. Okay, so 4 times 6 is 24. 4 times negative 1 is negative 4i. Negative 4i times 6 is negative 24i. And negative 4i times negative I is plus 4i to the second power. Now, let's add the like parts. These are the like parts, so that gives us 24. And that gives me negative 28i. Now, I have an I squared, and remember that I squared is equal to negative 1. So I have negative 1 times 4, which is negative 4, and I'm going to add this negative 4 and the 24 together, giving us 20 minus 28i. And we're all done. Okay, let's take, you know what, I want you to play with the next two. So first of all, go ahead and do C, and then go ahead and do D, and then unpause me, and then we'll talk about it together. Okay, now that you've done this, let's see what we have here. Okay, so first of all, we have 3 times 3, which is 9. 3 times negative 2, which is negative 6i. 2i times 3 is plus 6i. And 2i times negative 2i gives us what? Well, that is minus 4i to the second power. Now, these two are going to subtract out because negative 6i plus 6i goes to 0. And I'm left with 9 minus 4. Now, hold it here. I squared was equal to what? Yes, negative 1. So that's the same as 9 plus 4, which is 13. And that's what those two equal. Now, a little hint here. You see these two? They are complex conjugates of each other. But we're going to learn that more next class period. Okay, let's take a look at these last two. Here, let's see, what do I have? Well, let me change pen color again. And let's go back to, and how about light blue? Okay, so for this one here, we have 4i times negative 3i. Well, multiply that together. 4 times negative 3 is negative 12. I times I is I to the second. I to the second is negative 1, so it's going to be negative 12 times negative 1, and negative 12 times negative 1 is 12. And there I go. Well, guys, that's going to give us a wrap up for today. We're going to wait for the division until next class period. So your homework for tonight is, we're going to, in our textbook, 12 to 26 even, and then 46 to 60 even. And we're going to be working on section 5-9. All right, folks, I will see you in class.